Hello there. In this video, we will talk about strong and weak acids. So as you can see in the list, some of them are categorized as strong acids while the others are called weak acids. So we're going to look into what makes an acid strong or weak. A generic formula for an acid would be HA. When dissolved in water, should provide H plus ions. So we get hydronium and the anion. Now in the case of a strong acid, for example HCl, HCl is supposed to ionize 100% to produce H plus and Cl minus ions. The chances of these ions to recombine and make the acid again is extremely low. Therefore, if I had 0.1 molar HCl, it can be expected to provide 0.1 molar H plus ions as well. So concentration of H plus ions that is received from 0.1 molar HCl acid would also be equal to 0.1 molar. However, it's not the case with a weak acid. For example, acetic acid. This being an acid will also provide protons in water. However, in this case, these ions have a huge tendency to recombine and make the acid once again. Therefore, dissociation of this acid is not 100%. On the contrary, dissociation of a weak acid is extremely low. What that means is that if I have 0.1 molar acetic acid, it's not going to provide me 0.1 molar H plus. It's going to be much less than that. We can model that also. Alright, so let's say that the first group of molecules are the molecules of a strong acid. When these acid molecules ionize in water, we're going to see that all of these 5 molecules will dissociate into its cations and anions. So there is no molecule of a strong acid remaining in a bonded form. However, if you want to see dissociation of a weak acid, most of these molecules will stay the way they are. Probably one of these 5 might dissociate into its anion and cation. So here's how the ionization of a strong acid would look different from the ionization of a weak acid. The ionization of a weak acid looks like this. This is a particle diagram where you can see that most of the molecules are undissociated. Very few of them have H plus and the anion. However, if you're looking at the particle diagram of a strong acid, not one molecule is undissociated. It's a 100% separation of H plus from its anions. Hope you found this video helpful. If you would like to leave us some questions, do not forget to email us at chemrocks@cfisd.net. And if you would like to call us, the number would be 1-888-LOVE-CHEM. Bye-bye.